Hello, Science 10, and welcome to Lesson 2 on the theories of thermal energy or theories of heat. So we're going to start off by talking about three of the very earliest theories, essentially, that are essentially all wrong and what led us to understanding how heat actually works. So at the very beginning, the Greeks believed that fire was one of the four basic elements: earth, wind, water, fire, earth, wind, water, and fire, right? So those were the four essential elements. And when something was heated, fire was released. So that's how they understood essentially heat or thermal energy in the beginning. As time moved on, they did then develop something called the phlogiston theory. Now, the phlogiston theory was a belief that there was a substance that substances that burn contain this invisible fluid we'll call phlogiston. And this phlogiston flowed from the object when it was burned. And when wood burned, the phlogiston left the wood and left only ashes behind. So that's what they believed was happening. So they believed that the fire had this invisible fluid called phlogiston, and when it was gone, all you were left with was ashes. That moved on into a new theory called the caloric theory. And this proposed that caloric or heat was a massless fluid found in all substances, and that it always flowed from warm to cold. Okay. This could explain most observations of heat and actually led to the unit of the calorie. But a man along the name of Count Rumford, actually disproved this. When you think about friction, something that's warm and rubbing against something that's warm, there was no flowing of energy from warm to cold. So it was disproved, and it was shown that all of these theories were wrong. Yay, right? Isn't that wonderful how that always works? A theory is proven wrong. So what ends up happening, though, is we were able to come up with our summary of thermal energy or heat. Thermal means heat, guys. So please be aware that those two words are going to get interchanged. This is what thermal energy really is. Thermal energy is due to kinetic energy or movement energy of all the particles inside of it. So let's sum up thermal energy versus temperature, because we tend to when we talk about things that have thermal energy, we say, oh, it's got a really high temperature. When in fact, we have to be very careful. These are two different things. Heat or thermal energy is different than temperature. So thermal energy is what we say is the sum, so all of it, the sum of all kinetic energy in a substance or system. So we look at everything that is kinetic energy or everything that is movement, and we add it all together. That is the sum of kinetic energy in the substance or system. This kinetic energy is due to the fact that we have random movement of particles. So if you think back to particle theory, they're always moving. And we know that the hotter something is, or the more heat something has, we'll say, the more movement of the particles occur. Okay, temperature is the average kinetic energy of the particles in a substance due to this random motion. So all of these particles have this blank amount of energy. So it's an average. So please watch the video posted right now, because it's going to help when we talk about this bucket and tea example. It's going to give you a better understanding of what we're talking about. So now that you've watched the video on the bucket and the small teacup, we're going to talk about how do we compare these. So you guys have the analogy of a pail of water at 50 degrees Celsius compared to a cup of tea at 100 degrees Celsius. Just very similar to the video you just watched. So if we're talking about the movement of particles in that water, because 50 degrees Celsius is cooler in temperature than the 100 degrees Celsius, we know that its movement of particles is actually slower compared to the movement in the tea, which is much faster. All right. Now, when we look at this, we will refer to this as degrees of hotness, which is also a word for temperature. So in your brackets in your notes, degree of hotness is temperature. Now, temperature takes into account the speed of the molecules. So if we notice that the water in the bucket is moving slower, we would say that it has a lower degree of hotness because the speed of the particles is lower. Much lower movement of those particles, and therefore the temperature is lower. On the other side, because the movement of the particles in the teacup is really fast, okay, that means it has a higher degree of hotness or a higher temperature. But when we look at a system and we were talking about thermal energy or heat, which is what you can put under the quantity of hotness, when we talk about that, we're not just looking at speed, we're also taking into account mass, how many particles there are, okay? So if we look at the number of particles found in the bucket of water is much bigger, much bigger, okay? Therefore, it has more particles. The cup is really small, so it has way less particles in it, significantly less. They're two different sizes. One has way more water in it than the other. So when we compare its quantity of hotness, or what we would call heat or thermal energy, which you can put in the brackets on your notes, we would say that the bucket has a much larger quantity of hotness because it has more mass and the movement of particles, where this other one has a smaller amount of particles or smaller number of particles, so therefore its quantity of hotness is smaller. So if we're summarizing our ideas, we would say the temperature of the bucket is lower, hence why I have it in lowercase, but the thermal energy is quite big, so that's why it's capitalized. So in summary, temperature is lower, but overall its thermal energy is bigger. Hence why if you dump the bucket of water into a cold swimming pool, it helps warm it up because there's more particles of it spreading out its amount of energy across the board. The teacup, on the other hand, has a very high temperature. Okay. It's got really fast moving particles, but there's not enough of it to spread out in a pool. So therefore, it has less thermal energy or heat. So we're going to look at the piggy bank example. Now, your piggy bank example and my piggy bank example, unfortunately, are different, and I did not realize it until I started this video. So what you are going to do is I want you to take the time to figure out how much money is in piggy bank A and how much money is in piggy bank B based on your two pictures. And then I want you to try and figure out which one has the higher temperature and which one has the higher thermal energy. And then I will get you to post your answers and I will tell you if you are right or wrong. So the type of movement that is taking place also really depends on the state of the matter. So we talked about the movement of particles. You have to remember that solids, liquids, and gases have things moving differently. So in our example, we talked about liquids. Liquids have particles that are a little bit more freer to move around, but they're still confined in the liquid itself. Gas can be all around us and they can pretty much move in any direction, or solid are tightly packed together. And even though they're vibrating, they're not moving in a bunch of different places. So in a solid, like I said, particles are mostly vibrating. Liquids, it's rotating, and gas is primarily transitional movements, which just means that they're all over the place pretty much when it comes to gases. So if the temperature is the same for two objects, so let's say on average particle, both objects has the average particles in both objects is moving the same amount regardless of the type of movement of state. So what we mean by that is if we are looking at something like ice and water, okay, ice at 0 degrees compared to water at 0 degrees, okay, is going to be the same. The temperature is the same, okay, but the thermal energy might be different because ice is a solid and water is a liquid. Okay, water at 100 degrees compared to steam at 100 degrees, okay, it's the same amount regardless of the type of movement because states are different, but you can have different types of states at different temperatures. So we are going to talk about heat versus energy in class. So please make sure you have these all listed in your notes and I will talk to you soon.